In this video, we will give you an introduction into our advanced configuration tool, a powerful and easy to use Windows software package, which you can use to create configurations for flexible gateways from our CANnector or FRC series of products. Hello everyone, my name is Tobi and today I will show you how to create a simple gateway configuration for our CANnector and FRC Gateway product families. We will create the configuration using our advanced configuration tool, ACT, where you can exchange messages between a regular CAN 2.0 and a CANFD network by using the Ixxat CANnector S device. Let's go! An example of this type of exchange would be in a testing station that is only capable of connecting to a controller area network, using CAN messages rather than the newer CANFD protocol. The CANnector in this case is an entry-level automotive gateway which enables communication between different networks and protocols within a vehicle. In this particular use case, the CANnector is likely being used to bridge the communication gap between the testing station and the CAN network, allowing the station to send and receive CAN messages. To configure the CANnector, we are using the ACT, a user-friendly Windows-based software that enables the creation of configurations for CANnector and FRC EP devices. It offers features such as logger, gateway, user code, visualization, MATLAB and EtherCAT, RBS and signal manipulation and many more. Additionally, it enables the implementation of CAN, CANFD gateways and data visualization functions on HTML5 capable devices. This versatility and compatibility with all hardware devices make it an essential tool for automotive testing and simulation, while its drag and drop functionality and USB licensed dongle provide ease of use. We've already talked about the differences between CAN and CANFD in an earlier video. Now, I want to show you how easy it can be to bridge all data from a CAN network to a CANFD network using our products. You will also gain a basic understanding of how to use the advanced configuration tool, where I will explain the main functions. Maybe you ask yourself, how would that be interesting for me? Well, I show you a use case where it will be interesting for you. Let's assume we want to read CANFD data from an electric powertrain inside of a vehicle during a test run, but your test environment only provides CAN 2.0 connectivity. With our products, you can easily convert between CAN 2.0 and CANFD to give your existing equipment access to different standards. First, on our PC, let's navigate to the advanced configuration tool and start it up. The download instructions for the tool are included when purchasing a CANnector or FRC series product, but you will also find the link in the description below. Here we go. Now let's choose the New Project wizard from the toolbar. We want to create a gateway, so we select Gateway from the Project Template section. Now click Next and select the Ixxat CANnector S from the Target Platform pane. Again, press Next. You will see that the wizard has automatically added 4 standard CAN 2.0 channels to the configuration. Select CAN 1 and press the French symbol to edit the communication setting for that CAN 2.0 channel. Here you can edit communication parameters such as bitrate, frame, format and various other communication settings. For this example, we want to stay with the 500 kbits per second preset for the bitrate and standard for the frame format. Press OK to close the dialog box. Now press plus to add another CAN channel. You can ignore this dialog in the example by just pressing OK. We want to keep it simple and easy today. Now we will adjust the settings on the CANFD part of the network in this dialog. Again, we will stay with the standard frame format and keep the bitrate at 500 kbits per second. But now, as we want to use CANFD, we click on the Flexible Data Rate checkbox to allow us to set the fast bitrate timing. We will use the 2000 kbits per second preset for this example. Press OK to close the settings dialog and press Next to go to the final step of the wizard. Name the project My First Simple Gateway and press Finish to close the wizard. Half of the work is already done. Check! The basic settings are made. I told you it was easy. Now we want to transmit every message from the CAN 2.0 network to the CANfd network. To do this, let me first tell you a little bit more about the setup of the ACT tool and how to use it. You see the window divided into 3 panes. The first pane is the source pane, where you get all information on the structure of the incoming data. You can select the bus you want to examine by clicking on the different tabs to view their configuration. At this point, we have not imported any communication information, so there still is a blank setting. We will deal with this in one of our next videos. The second pane will give you information about specific data structures when imported. Also left blank for this video. In the third pane, the mapping pane, you will see how the data is mapped from source to destination. Now I will show you how simple it can be to connect one bus to the other. Click on CAN1 in the source pane to select CAN1 as one end of the gateway. Then we select CAN5, that's our CANfd network, in the destination pane. As you see, the destination pane now divides into 2 separate sub-panes. One for each direction, meaning data to be sent out to CAN5 and data to be received from CAN5. Now we want to send every message coming in from CAN1 out on CAN5, our CANfd network. Here we simply drag the CAN1 tab from the source pane to the To destination pane. The little asterisks show that every message shall be transmitted. We call this a wildcard mapping. This is all we would need to do for now to send data from CAN 2.0 into a CANfd network. You can now generate the configuration by clicking the Build button and then download the configuration to your gateway hardware, in this case the CANnector device. And you are ready to go. Okay, we've done one direction, but what if we must send data back from the CANfd network to the CAN 2.0 network? Of course, we also have a solution here, but unfortunately it's not as easy as the solution before. CANfd messages can be much longer than CAN 2.0 messages, so our gateway must understand how to organize the data from CANfd messages into messages that can fit into smaller CAN 2.0 format. To achieve this, we can tell the gateway what messages are expected and how the data is organized. Therefore, you need a database file describing the structure of the message. Our tool can work with several of these database formats, including CANDB or ARXML. To accomplish this, we first need to remove the existing gateway mapping. Now we can attach to our CANfd bus. You remember that was our CAN5, the CANDB file. For this example, we will take one of our demonstration database files provided with the ACT. Now we redo the steps as before to configure the data transport from CAN 2.0 to CANfd. In the next step, we will select the data that will be sent from CANfd to CAN 2.0, so we select the car CANfd in the source pane. But why is it not CAN5 anymore? Well, we're using a CANDB file, and in this file there was a name defined for this specific bus, which is now shown in the tab. Now we see the different ECUs. Here we will select the ENG-stat ECU for data from the engine. So we go to the PDU tab of the ENG-stat entry and select PDU on the destination pane of CAN1. Now we drag the ENG-stat PDU to the destination pane. Again, we build and download the configuration onto our CAN device, and this is all we need to do for now. In summary, we have shown you how to bridge data from CANfd to CAN and vice versa in a very efficient and failure-proof way. No program is required. You are working with data definitions, so you don't need to deal with complex bit juggling. We hope you enjoyed this video. please check out our other ACT videos too for more information on our other products. Thanks for watching, and if you like this video and you want to support us, please leave a like and follow our channel, and of course you can leave comments too. Bye bye, see you next time.